Let's focus on some of the improvements and anomalies of the system which we have built it before, and then we will go through some of the deep dives of the system. The system which I built before, it had some issues before. First of all, the first one is the about the ride schema update here. Here, I also needed to add the source location and destination location of some specific ride that will properly make sense related to the ride. Ride will always contain source location and destination location, and then secondly about the driver. Driver will also contain its current location always present in its schema. And then secondly, where is our API section here? Here in this section, these were our public APIs like get estimates and create ride. We need to create one other one. It is related to the update location. Like there will be some specific point when always the drivers need to update their location into the database. Like after, as we discussed, after every 5 seconds. So how it will be done? It will be done by basically post update location, and it will be returning the uh, success or error and something like that, and its body will contain latitude and longitude configuration of that drivers. So these will be saved into our database, our locations database. This was also missing before. It is an important part of important public API present. And then another API that is also related to the driver here, that is about when driver will be accepting or denying the ride. At that time, we also need to properly we will be giving 10 seconds for each driver. Within that 10 seconds, user can accept a ride or deny it, but obviously after 10 seconds, it will be automatically denied. That and right here, that is also an important public API here. We can call it update ride API, and that update ride API will be accepting two statuses here. It will be either accept or deny, and this will be returning status like success or error, or we can decide true or false. It doesn't matter. So yeah, that will also be. Or what I am thinking is because this will be updating the ride, so this will not be a post request, but instead that would be a cache that affects me. Update location, I think that would also be there will be some already that will also be a cache and not post, because there will already be some instance of the location present of the driver, and we just need to update it. Okay, these are some of the updates which I needed to do before. And there is one more thing about that how will we properly scale this system to handle about, let's say, 10 million drivers in some specific area.
Okay, let's focus our attention to some of the deep dives, and specifically, let's focus on this location database first. We are facing some problem here. Let me just do some writing here. Deep dives. In deep dives, what is our first problem? First problem is how will we handle proxy, unity, search, and frequent location. Right, let's put it that way. Okay, what we are trying to do is, let's say we have about 10 million drivers. So for that 10 million drivers which is present in the location database, we have not yet decided which database we are using. Either we can use any SQL like PostgreSQL or AWS DynamoDB. And then for these 10 million drivers, each driver is sending its request about in every 5 seconds. So it becomes about 2 million writes per second. Each million user, 2 million writes per second. Each user is sending its location to database in 5 seconds. And this is about writing. And then about reading, we need to, matching service will be doing the proximity search to the whole database. It will be searching the nearest drivers, and obviously that needs to do the search on the whole 10 million drivers. So yeah, that's a huge number. We need to properly minimize this, handle this. We have seen few options. Let's discuss all of those. First option is obviously what will we do? We will direct search on DB. Well, we are considering both reading and writing here. search on DB in case of read, and along with the query, we will perform some query that that driver is nearest to that writer. And in case of writing, what we will do the direct writing of DB as well. Let's take some examples. If we are using AWS DynamoDB, then AWS DynamoDB costs about $1.25. That is its latest rate as per April 2026. DynamoDB costs about $0.25 per. Let me just confirm it. It costs about per million. Per million read units. This is called write read units. So keeping that thing in mind, for 2 million writes per second, this will become about this will become about $200,000 per day cost for DynamoDB. So that is a huge cost if we are just doing a simple writing request to AWS DynamoDB. In case of let's say Postgres, what is our cons? That would be slow. It will be not as fast as compared to DynamoDB because Postgres is SQL, but still cost there comparatively not as much costly as DynamoDB, but still that would be costly as well. So this our first option of using direct search on DB in case of read and write. This is we are considering in case of both direct read. This option is not feasible. So keeping that thing in mind, where do we have a second option? Second option is in case of reading, we can use geo-special database. Like in case of Postgres, we can use transform. We can transform Postgres to PostGIS. Postgres with the extension with the plugin of geospatial indexing. So these are very fast in case of reading. Let me also give you an example that how these geospatial databases work. And in case of writing, what we can do? In case of writing, we can use batch processing. That is our option. How we can use batch processing, like we have a location service present in between. This is our location service. Location service is taking location of the driver every 5 seconds. But exactly at that time, location is not updating our driver location update database. It will batch them. It will save them at some other time. That one option is that we can use any message queue in between, like Kafka. And Kafka will be batching all of the locations. And let's say after 2 minutes, after 3 minutes, it will batch all of those locations and it will update to the driver's location database, or drivers can pull it after 2 minutes. So that is one of the options. But obviously, the downside of that would be the extra infrastructure cost in case of this. We'll be batching, we will be using one extra layer so that is also a little bit costly because we are using one extra infrastructure cost, one extra component we are using here. We can use batch processing, or we can, even if we are not using any third-party component like Kafka, applications can use its own cache for processing as well. But still, that is also one of the options in case of writing. What on of this would be extra infra cost. That is one of the options. And then also let me discuss that how geospatial databases will work. That is also the options which instead of a direct reading from the database. Geospatial databases work different than the normal databases work. Let me give you an example of that. We have these such kind of rows present in a normal database. And what does the normal databases like MySQL, Postgres will do, even if we have indexes present? But normally what they do the searching by row by row searching. First row search, second row search, third row, fourth row, and they do the searching in this way. They skip some of the rows based on the indexing, but the normal search goes like that way. So it is a very expensive search if we are using the 10 million rows and we need to do it very efficiently. Our non-functional requirements includes the highest availability and low latency. And then we have another option of geospatial databases. They use the quad trees under the hood data structure, and using quad trees, they divide their data into 4 chunks, and then they keep on searching it cursively. First, they will divide that way. They will figure out that their target is in one of those. Then they will further divide that chunk into 4, and then it will further keep on dividing its targets until they reach their target. So yeah, that is a better approach. That's how your special databases work. So that will be our better option to use in case to properly implement the geospatial location, properly see our location databases. So yeah, that's what we will do. That is our better option. What is our downsides of this? Because our first downside is that it would be extra infra cost in case of read, and in case of reading. In case of writing, we have an extra infra cost. In case of reading, still we are saving data in hard drives or SSD, we can say, slow as compared to memory read. We have a third option present, and that third option is using. That's the best option so far. That third option is using the Redis in memory data store. Data store with the geospatial, or we can say geocaching features. That is the best option present so far. It will resolve both of our reading issues and writing issues, both reading and writing. How? Because reading, if we are doing reading on Redis and is in memory, then it will be fast as compared to searching from our hard drives. So it is very, here we are, Postgres databases are saved on if we are doing the searching from hard drives and SSD, and if we are searching from the memory, from the RAM, obviously that reading will be fast. And same goes with the writing. Writing, we don't need to do batch processing anymore. We can do this efficiently by using the writing on directly our geocaching database, and under the hood, it is very efficient, and it can handle that traffic of about 2 million writes per second. And now, what is our downside of this? Cons of this approach. Basically, first is the not persistent. Our data will not be persistent in this case because we are using our data in memory, but we are solving our latency problem. So that is a latency and throughput problem solved. To solve these cons of this, what we can do, we can use we have some options of storing the Redis in what options we have. We have some options of using Redis persistence or Redis Sentinel. These are a few of the options we have present in the market. We could enable Redis persistent mechanisms like Redis database or append only file to periodically save the in-memory data to disk. Or we can also use Redis Sentinel for high availability. Sentinel provides automatic failover if the master node goes down, ensuring that a replica is promoted to master. So yeah, that's the option. We have solutions present to this problem of not persistent. We can use Redis Sentinel, or we can use Redis database. That are the few options we are present. We are not going to deep down directly into these data, how they work and how they don't work, but that is the best option so far we have to solve this problem of location databases. So let's update our location database, Traverse location database. We are using Redis here. That is our final DC.
We have some further deep dive questions which interviewer can bring on during the interview. And the first one from that is this one. It basically says that how can we manage system overload from frequent driver location updates while ensuring location accuracy? We partially solved this problem in a previous question. That what we were doing, we finally decided that we will be using Redis geohashing database in memory data store, and then we can also use Redis database or Redis Sentinel at some time asynchronously to transfer the data from in memory to some persistent database. So But still, the thing is that we are doing about 2 million writes per second applications. We need to properly optimize this further. Why we need to properly doing something in a whole system to make it further less? Do we need this whole 2 million writes per second, or we can further do this? What other options we have? Uh, One thing is on the client side. Driver mobile app is doing the location updates. So here the solution is present at this level. In the driver mobile app, we need to further optimize this thing that there will be some answers based on driver's direction. We can decide the algorithm is not the final, but we can further optimize this in the driver mobile app based on driver's direction, speed, activity level. Like if the driver is free or maybe driver is inactive, then we don't need to send notification. That is also a thing, and further we can further optimize this. But the main answer of this question lies within the driver mobile app. There is not any other option behind that based on these different directions. Like if the driver is in some such area where there is not any chance that there will be any rides coming in that area. Then based on area, we can decide. Then we don't need to send the location of the driver at that time. We need to, like, if the user is present in some congested area, then we can further from 5 seconds to 2, we can further decrease it to 2 seconds. But in case of some unpopulated area, we can further decrease it to like 20 seconds, 30 seconds, or don't even send in that area. These are few of the options which we can do. So this will be basically adaptive location update intervals, which we can do here. Okay, the main challenge with this approach is the complexity of designing effective algorithms to determine the optimal update frequency. This requires careful consideration and testing to ensure accuracy and reliability. But if done well, it will significantly reduce the number of application updates and improve system efficiency. We cannot deny the client side properly. That is normally what is done at in system design interviews, that we are properly just focusing on the backend side. But if we put some focus on the front end on the client side, then there are optimization chances from that side as well. Okay, what other questions we can come up in a system design interview, specifically in the deep dive section, is this one, This basically is saying that how do we prevent multiple ride requests from being sent to the same driver simultaneously? We have this driver, and from the matching service, what we were doing from the matching service, we were creating an event notify driver in the Apache Kafka, and then the Apache Kafka notification is pulling that event from the Apache Kafka and sending that notification to the driver mobile app. So in this whole section, how we can improve this? How can we make sure that one driver will be notified and assigned only one ride at a time, or let's say will be notified at only one time? The whole answer relies in this matching service. So what are the different options do we have? What other options? First option is that we log in matching service. Like this matching service will be we lock it internally, that it lock matching service in its local storage or its local cache. It will lock this driver so that no further ride can be assigned to it, and we will not notify this driver further. But what is the issue in that? Issue is that another instance of matching service can still notify and assign that driver. So that is the main downside of this. We are in a distributed system. There are multiple instances of that matching service present. So local locking will not work. So then we have an option lock in database. That is a better option. Like how? What will we do? We will get the status of the driver from free to let's say notified. So in the database we will do this, and when any instance of the matching service, we will get to know before notifying that driver. We will make sure that the status of the driver is not notified, and if the status the driver is free, then they will notify the driver. That is a better approach, but it has also some downsides present. What if the matching service it is the main downside of this approach is that when we will be updating the driver again from notified to free, we are relying on any memory timeout of the matching service to do that again. Or we can run some cron job as well to periodically check for locks that have expired and release them. This works, but adds unnecessary complexity and introduces a delay in unlocking the right request. So yeah, that is also the main downside of it is relying on in-memory timeout to release the driver again. And what if the matching service goes down? Then that driver will be in notified state forever. So what is the final option we have? What final option is the distributed lock. That is the full and final option, best option we have. We will create some third-party Redis store to create some locks for the drivers. What will it contain? It will contain driver ID, time to live TTL. After that TTL, the driver will be free from this lock.